Hi everyone, my dear subscribers, you're welcome to Muhumuza Naphtali, medicalsciences.com here in Uganda, and particularly in Murago. And we are called to serve you under what we call education services. And that's why we are making these videos under biochemistry and clinical chemistry to make sure the medical students are able to be enhanced, equipped with knowledge to help our patients outside there. So today, we want to talk about lipoproteins and how they are determined in the laboratory to help our patients who have high lipids, or what we call hyperlipidemia, to be diagnosed and get right treatment. So let's get started on lipoproteins. So lipoproteins, it has two words, lipoproteins, meaning it is a compound lipid made up of what? Lipid and proteins. And these lipoproteins, their major function in the body is the transportation. Transportation of lipids. So they are the ones responsible for transporting lipids in our body. Without lipoproteins, these lipids might not move into the blood saturation. But it is the lipoproteins that enable us to move lipids from one place to the other. So these lipoproteins, being transporters of lipids, they are categorized according to the density. These lipoproteins, they are categorized according to their density and size. But majorly the classification is according to the density, whereby the first one being chylomicron. We are going to draw a table, and this table, we are going to have a lipoprotein in one column. Then in another column, we are going to have the apoprotein found. The apoprotein found on each. Then the last table, the last column, which should be bigger, it has the function. I can summarize it in a table, whereby the first lipoprotein we want to talk about is the chylomicron. The chylomicron, others call them chylomicron. The chylomicron is the one with lowest density. It is the biggest, but the lowest in density. It is less dense compared to others, but in size it is the biggest. So, being the one with the lowest density, the chylomicron, the apoprotein present on its surface is ApoB48. ApoB48 is the one found on the surface of the chylomicron, and as I told you that chylomicron, the major constituent is the triglyceride, whereby 90% are tags to transport triglycerides. And these triglycerides, they are exogenous, the ones we eat in our diet. So the function of the chylomicron is to transport dietary lipids, dietary triglycerides, triacylglycerol, or you can call them exogenous, from where? From intestines to adipose tissue and the skeletal muscles. So this is the role of the chylomicron. Chylomicron, the way we saw in absorption, it is the one, it has a ApoB48 which acts as a receptor, and it is responsible for transporting dietary triglycerides, or what we can call dietary or exogenous triglycerides. Don't say it transports lipids. No, it transports dietary triglycerides. From where? From the intestines to the adipose and skeletal muscles. You must tell us where it comes from, where it is bringing it from, and where is it going. That is the function of the chylomicron. And the major apoprotein, this one is the major, ApoB48. will be 48. Then the next one is from the chylomicron. When it is being broken down, it is broken down into what we call very low density lipoprotein. We call them very low density lipoprotein. Broken down, or when it is being metabolized, when we are removing triglycerides, now we form what we call very low density lipoprotein. And this very low density lipoprotein, the major apoprotein on it is ApoB100, and this ApoB100 being the major one, this very low density is responsible for transporting. It transports endogenous triglycerides from the liver to adipose and skeletal muscles, adipose tissue and skeletal muscles. This is the role of very low density lipoprotein. Very low density lipoprotein being manufactured in the liver. So, any fat formed during lipogenesis, any triglycerides, we remember in the liver we have the process known as lipogenesis. So, any synthesized triglycerides in the liver are transported by very low density lipoprotein. As we have seen the chylomicron, for them they are bringing in the dietary, the exogenous, but the very low density transport the endogenous. The triglycerides which have been synthesized by the body. That is the role, and the major apoprotein is ApoB100. Then another type of lipoprotein is low density lipoprotein. We don't want to talk about intermediate density lipoprotein, because when very low density is being converted to lipoprotein, the intermediate is what we call intermediate density lipoprotein, but it doesn't play a major big role. So we go directly to low density lipoprotein. And this low density lipoprotein, also its major apoprotein is ApoB100. And for it is responsible for transportation. It transports. And now as we are breaking down triglycerides, by the time we go to low density lipoprotein, all the triglycerides have been used up. We are remaining with the cholesterol. So now this low density lipoprotein transports cholesterol, not triglycerides. So it transports cholesterol from the liver to adipose tissue. Actually, we can say to the peripheral tissues, because it is not only adipose, to peripheral tissues. Peripheral tissues include blood vessels, include all peripheral tissues, is where we see the low density lipoprotein transporting. Here the keyword is the cholesterol. Cholesterol, here we are seeing keyword being endogenous triglycerides. Here the keyword was exogenous triglyceride. But this one is cholesterol. It is transporting cholesterol from the liver to the peripheral tissue. That's why we normally call it a bad cholesterol. That low density lipoprotein is a bad lipoprotein, or it is a bad fat. Why? Because it keeps building up lipids within the vessel walls. And this one can keep building, forming what we call a plaque or an atheroma. And this atheroma can block the blood movement, leading to what we call atherosclerosis. And when atherosclerosis persists, can lead to arteriosclerosis, and then even hypertension, and even stroke. So it is not a good one. So whenever we do it in the laboratory and we find our patients have high LDL, we need to see what to do for them. Because the moment it continues to be high, it keeps depositing these fats into peripheral tissues, majorly the blood vessels. Then the last lipoprotein, which is the one with the highest density. Because we know that that's why we call it high density lipoprotein. And this high density lipoprotein is known as a good fat. And this high density lipoprotein is the one that has ApoB, ApoA1, it has ApoA1, and it also has ApoC2. ApoC2 contains ApoC2, and it also contains ApoE. High density lipoprotein is the one with the highest density, and we are calling it a good fat. And we are saying on its surface it has 3 apoproteins: ApoBA1, ApoC2, and ApoE. And for it is very good that it keeps donating it all. If we want to break down triglycerides, HDL keeps donating to chylomicron, and ApoC2 is the one that activates lipoprotein lipase. Whenever we want to break down fats by lipolysis, we need ApoC2 from HDL, and it is ApoC2 that activates lipoprotein lipase. So HDL, it is always in the saturation moving, and as it is moving in the saturation, it keeps donating ApoC2 and ApoE to all. That's why we were using major. So we cannot start putting ApoC2 here, because they acquired it from HDL. And after doing its work, then HDL says, bring back my ApoC2. So these are the major apoproteins there. And its role is reverse cholesterol transportation. It transports cholesterol. Transports cholesterol from peripheral tissues, to the liver for excretion. As we know that cholesterol is excreted in bile. So this one being a good cholesterol, for it goes into the blood vessels, into the body tissues, and picks out cholesterol and brings it back to the liver for excretion. Hence being a good fat obtained from plant fats. So this is high density lipoprotein. So these are the only different classes of lipoproteins, and this classification was according to the density, beginning with the lowest density, ending up with the one with the highest density. And we have seen different apoproteins and different functions, where I have emphasized that the first two carry triglycerides, whereby chylomicron is dietary, then very low density lipoprotein is endogenous. Then lastly is the LDL and HDL, which are transporting both cholesterol, but LDL is transporting it from the liver, where it is supposed to be excreted, and is taking it back to the peripheral circulation. Then this one is taking it from the peripheral to the liver, hence being a good fat. So after understanding different classes of cholesterol, of lipoproteins, how do we diagnose? Because there is an equation we use to calculate different lipoproteins. And we know that these lipoproteins measure the ones we use in diagnosis in the Friedwald equation. It is what we call Friedwald equation. And this Friedwald equation, in the lab, we don't expect you to start buying a reagent for LDL. You can buy the reagent for total cholesterol, for HDL, and triglycerides. and triglyceride. Then you can use this Friedwald equation to calculate the concentration of low density lipoprotein. So in this generation, we don't expect you as a medical student, especially a laboratory student, buying a reagent of low density lipoprotein. We can always use Friedwald equation, whereby this Friedwald equation says that LDL, if I'm calculating LDLs in millimole per liter, it is equal to total cholesterol. Is equal to total cholesterol minus triglycerides, then minus HDL, minus high density lipoprotein, then minus triglyceride divided by 2.2. That is when it is in millimoles per liter. That is the formula. And this formula, as a laboratory student, you must always make sure it is always in your hands, because we need it in the lab when we are calculating the levels of LDL. But if I want to calculate LDL in milligrams per deciliter, LDL is equal to total cholesterol minus HDL minus triglycerides divided by 5.0. Some books give 5.5, but the ideal is 5.0. So this is the Friedwald equation. So it is the one that we use to determine the concentration of low density lipoprotein. That if I have total cholesterol, I can subtract HDL, I can divide this by, we can give an example. We want to assume an example. Assume in the laboratory you have get a patient and his total cholesterol is 220 milligrams per deciliter. And his HDL was 50 milligrams per deciliter. And his triglyceride is 160 milligrams per deciliter. So given that total cholesterol is 220, high density lipoprotein is 50, and triglyceride is 160, we can say calculate levels of LDL, isn't it? And here we apply Friedwald equation. And because the values are in milligrams per deciliter, we are going to apply equation in number 2, whereby we know that LDL in milligrams per deciliter is equal to total cholesterol minus HDL minus triglyceride divided by 5. And whereby total cholesterol is 220 minus HDL, which is 50, then minus triglyceride, which is 160 divided by 5. Then we shall get, what is 220 minus 50? That is 170. Then minus, what is 160 divided by 5? Get 42. 32. Then finally the answer of LDL is equal to 170 minus 32, which is 138 milligrams per deciliter. Then they can say comment on the results. Comment on the results. We are seeing, we know that the reference ranges, here we now need to know the reference ranges. The reference ranges of different We have total cholesterol, we have triglycerides, we have HDL, we have LDL, whereby total cholesterol its range is up to 200 milligrams per deciliter, and triglyceride is 40 to 150 milligrams per deciliter. Then HDL is always 40 to 78 milligrams per deciliter, and LDL is always, this should be always below 130 milligrams per. So these are the reference ranges. So having these reference ranges, we can easily interpret these results, whereby we are seeing this patient's HDL is slightly high, isn't it? Is slightly high, and even his LDL is slightly high, isn't it? Because there is also classification, whereby they tell you when the total triglyceride is between 200 to 230, that is mild. Then 230, maybe to 260, it is moderate. Then greater than 260 is very high. So we classify. So we are seeing this patient is having what we call mild hyperlipidemia. Hyperlipidemia is high levels of what? Cholesterol in the body. And because his total cholesterol is slightly high, and the LDL is also slightly high, and we see even triglycerides being slightly high. So we can confirm that this patient is at risk of developing hyperlipidemia. It has started developing. So if this one might not need a medication because it's beginning, we can see lifestyle change, whereby we can tell him to do exercises and to reduce on the bad fats, isn't it? That one can be solved. But once it goes, you find total cholesterol going towards 260, that one needs medication of statins, whereby we can give them statins to try to combat these high lipids, so that we can reduce the risk of atherosclerosis. And the samples we normally use in the lipid profile determination, because this is what we call lipid profile. Whenever the doctor requests a lipid profile, the sample should be fasting. And this fasting should be between 8 to 16 hours. The patient must have fasted for 8 to 16 hours. That's when we get reliable results. Why? Because beyond 16 hours, still, we shall see triglycerides being mobilized due to starvation. After 16, we shall see gluconeogenesis coming in. And without fasting, we know that food we eat contains triglycerides. So when you use the non-fasting sample, you get false high triglyceride results. That's why we need to use a fasting sample. And there are many factors that affect, which we shall share in the next video. Keep updated at muhumuzamedicalscience.com, and always remember to like the video and subscribe so that we can keep moving. Thank you so much for watching. Next time we meet.